Okay, so yeah, hopefully everything will get back to normal soon. Okay, at least not normal, at least get back to semi-normal. Okay, I heard about the 他们讲什么I think 好像有好像是有我说好像是 I heard about the insider information about the MCO will extend until August. I mean it's going, but it's just they release like from one sector to another sector by sector they release. Okay, not at one go lah. So of course school will be the last lah. Your school, any other schools, the homeschool, the tuition center will be the last one. So will definitely be most probably be in the August. Hopefully that is not true. So if that's true, then we only continue the real physical class in August. So hopefully everything will get back to normal soon lah. Okay. So and now okay, let's start without further delay. Just start now. Okay, wait. Okay, let me get my whiteboard here. Okay, so I know it's hard to like keep yourself in front of a screen and learning from the screen all day. Definitely it's a bit hard, especially comes down to the motivation. You don't feel like motivated to learn online, right? Even if I were you, I also will feel the same. Okay, but understand that if you miss the lecture, then it's just like it's very hard to catch up everything. Okay, if you miss all the videos, if you miss the lessons, it's very you have to watch back the lessons and suddenly you have to learn everything at once. Okay, so it's very hard to catch back up, and especially when in this situation where your school, I don't know how your school teach you the way they teach. I heard about they record a video and then they play it for you. Is it they teach in the video something like this lah? Okay, I'm not sure, but understand that this is a since we are lagging behind. I mean, in terms of the real school progress is lagging. So just take this as advantage to practice more, okay, so that your basics, your foundation in Form 4 is okay, is firm already, 稳定了. Okay, Form 4 稳定, and then you go to your Form 5, then should be no problem here. Okay, so just nothing much. Okay, nothing much I want to say. Just continue. Let's continue. Now, work done, energy and power. What do you understand about work? It's not like the homework. It's not like the work you do every day. Okay, there's some relation to it, but I want the physics context. What do you understand about work? If I were to give you the direct formula, the direct definition of work, it is very technical. Okay, it is very technical, meaning that straight away I give you the formula. Work equals to force times distance, or you call it displacement. Okay, when you have force pushing an object over a certain displacement, then work is done. That's it, right? So for example, let's consider a system. A system, let's say you have a box resting on a surface. Okay, back in this typical example is whether usually we use car or box or anything. A box resting on the surface, on the floor, is, we call it a system. Okay, what does it mean by system? Is that system is a portion of the universe that you choose to study. Okay, I repeat, system is like a portion of the universe. a region in the universe where you choose to study or you choose to analyze. Okay, for example, like if I say this box is a system, meaning that you are only interested in studying this particular object. What are the forces acting on this object, or what is the changes that happen to the box, to this object? Okay, you only consider the forces acting on this particular object. Other than that, all the external forces, you don't care about it. Okay, 你不要理那种外面的 forces 什么，你只是专注在这个。So this is we call a system. All right. So it can be there are many systems. For example, collision of a car. Okay, car collision, that is a system. Okay, you only consider the collision. What are the forces acting in the collision here? For example, here, right? What are the forces? What are the forces acting in this collision? So outside of this collision, we don't care about it, right? So this one inside here, we call this a system. So system, you have many types. You have isolated closed system, but we're not going to go through that now. Okay, later maybe we'll go through that later. Okay, because there are also a lot. So just understand what is the meaning of a system here. Okay, so just to summarize up, a system is actually a specific event that we choose to study. That's it. Okay, now consider this system of box here resting on the ground. Imagine if I tie a string one end and then I pull it horizontally. Okay, so you're now exerting a force that is parallel to the ground. Okay, horizontal force. And then let's say the object moves at a distance here. Displaced, right? Displaced. Whenever the object moves from its original position, it ends up in a different position. We say that the object is displaced. Okay, which is why you have this called displacement. Okay, now what is the work? Is there any work done if I pull this object over a distance? Yes, straightforward, because there is force, there is displacement. Whenever there is a force and there is displacement, we say that work is done. This is the technical definition of work done. Okay, now later we'll go through a few of the examples for work done and work that is not done. Okay, now let's consider the second scenario here. If the same box here, the same string, instead of pulling it horizontally to the right, I pull it like this, upward at an angle from the horizontal. Let's say I just label theta. So this is my force, pulling force. Now, there's one thing I forgot to tell you, that for work done, the force and the displacement must be in the same direction. Remember this one, it must be in the same direction. Okay, so for example, the first example here, the force is acting to the right and the movement is also to the right. So we can straight away calculate the work done. But for example 2 here on the right, what is the direction of the forces? What is the direction of your pulling force? It's slanted, right? It's diagonal. It's diagonal. So if I say the object moves to a distance s, okay, now is there any work done? Yes. Why? Because there is force, there is a distance traveled. But what if I say calculate the work done for me? Since the force must be acting at the same direction as the movement, so you need to find this F in the horizontal direction, meaning that you will take F cos theta. Okay, you learn about the resolution of forces. This is a diagonal force, so you resolve it into the horizontal force. So F cos theta is the F that is acting horizontally. And this one, we want to take this force because this force is same direction as the distance traveled, the movement, okay? So in this case, we say that W, work done, equals to F cos theta times S. It's almost the same, just that the force, you resolve it, you change the direction, okay? So formally, you can write it as Fs cos data. This is your formula for work done. Okay, or you can write the more general one is W equals to Fs. Okay, the first one is general. The second one is used to calculate the force that is not in the same direction. So you have to consider the angle. Remember this one. This one is very important. Okay, consider the angle. Now, there's nothing complicated here yet. Now, let me ask you something. Let's say we have you are holding a bulb above, like 5 meters above the ground. You're just holding it. Just imagine now you're holding your physics book above 5 meters above the ground. Is there any work done if you don't move? You're just holding it. Is there any work done? You have to ask yourself that, is there any movement? No movement, right? No movement means no work done. No movement, no work done. So in this case, no work is done. But what if now you let go of your hand, let go of the book? Okay, you let go, the book starts to drop, right? It starts to drop. Why? Because due to the weight, the gravitational pull. So the book will eventually drop to the ground, and then it will travel a distance of 5 meters due to the gravity here. So in this case, is there any work done? Yes. Okay, because there is force, there is movement. So we say that work is done by the gravity on the book. Okay, so listen to the statement here. Work is done by the gravity. So gravity is doing the work, not you. Okay, you just let go of your hand, right? You are not doing the work. Okay, gravity is doing the work because it's pulling the book downwards, and work is done on the book. Okay, so work is done on the book, or you call it work is done on the system. Okay, there's a subtle difference here, a very small difference here. Okay, work is done by or work is done on. Okay, so in this case, is work is done by the gravity and work is done on the book. Now, second example. Imagine you are pushing a wall. Okay, so you're pushing a wall, but the wall does not move. Displacement is equal to 0. Is there any work done on the wall? Okay, you try as hard as you can to push it, but you still cannot move it. Is there any work done on the wall? No. Why? Because the wall is still stationary, it's not moving. Right? Now, the third scenario, let's say you are walking up the stairs. Is there any work done? Simply by walking up the stairs. Okay. First, this is your weight. What happens when you walk up the stairs? You need to lift yourself. Okay, you are technically, when you walk up the stairs, right, you are lifting yourself up. You are lifting yourself up, meaning that you are exerting an upward force that counters your own weight, right? You're exerting this upward force, and at the same time, you are moving up, right? You're moving up, so there is a vertical distance here. Let's take the ground level as the 0 meters. Okay, so straight up vertical, let's say this is 5 meters. So when you walk up the stairs, even though it is diagonal up, but you have displaced a vertical distance which is 5m. And why we take this height when we calculate work done is because this height is the same direction as your force. 你的 force 是向上嘛 because you are acting the lift force is 向上，所以你在算那个 work done 的时候是你一定要拿直线的 distance，直线的 displacement。You cannot take this one You cannot take this one diagonal. If you take diagonal, then wrong. Okay, so I believe I've made myself clear about this one. The force has to be the same direction as the distance, the displacement. Okay, so in this case, is there any work done? Yes, there is work done. Simply because you are creating a force to lift yourself to a vertical distance, to a vertical height. Okay, so these here are just a few very popular examples that in your exam, definitely you will see it. Okay, now another one. Let's do another one. Say you have say you are holding the same boat. Use my drawing. Okay, you are holding the same boat, and then you walk a distance. Displacement here. Imagine you're holding, you're not moving the boat up and down. You're moving, you're holding it still, but you yourself, you walk in front. You walk to the front at a distance. Okay, is there any work done? Is there any work done? Try to think for a moment. Is there any work done? Where is my force? Where is my displacement? Now, as you hold the boat, you are creating a lifting force, right? Same. This force must be equal to the weight in order for it to stay still in the air. So what is the force that you exert? Is this one here. Where is the direction of this force? It is acting upward. Okay. Now, where is your movement? To the right. What is the direction of your movement? To the right. Is the movement same direction as the force? No. The force is perpendicular to the movement. So if the force is not in the same direction as the movement, is there any work done? No. Okay, so the answer is no work done. No work is done on the book. I repeat, no work is done by you on the book. Why? Because force and displacement is in a different direction. And if you plot the force diagram, right, force is acting up, displacement is to the right, and this is 90 degree, right? 90 degree. So if you take the formula, work equals to Fs cos theta. When you take F cos 90 degree, what happens? You calculate cos 90 degree, you will get a 0, right? You will get a 0. So this one you will get 0. Work done is equal to 0. This one is using mathematical logic to solve it. Okay, so from all the examples just now, I believe that you have at least get a clear view of what work done is. Okay, so remember that when you're walking up the stairs, there's work done. You're pushing the wall, but the wall is not moving. There's no work done. And you're holding a book, but you're walking in front. There's no work done. Now, how about this one? If I tweak a little bit, the same question here, but instead of moving to the right, you're holding the book, you move up. Okay, I draw it here. Instead of moving to the right, you're holding the same book. Moving the same. Okay, you move up. Let's change this one to a stair. Is there any work done on the book? Yes. Why? Same, you label the force. This is your lifting force acting upward. And at the same time, you and the book is moving up. So there is work done. Okay. Next is energy. Now, energy is very closely related to work done. Okay. Now, think of energy like something that stores inside your body. Okay, we all know what energy is. Okay, we all know what energy. We all have an idea of what energy is. So think of it like something that is stored inside your body. Okay, now when you consume food, you gain energy, right? So what happens when you gain energy? You have this high level of energy inside your body, right? And you feel energetic, right? You feel energetic. Now what happens if you feel energetic? Just imagine if now you feel energetic, what happens? You can just go out and run the whole field, right? You can just go out, 你出去跑10圈、跑5圈都可以。You can go to the gym, you go to sports without feeling tired, just because of the state you are in right now. You are in this very excited state, this very active state, right? So if you really think of what energy is actually the ability of an object to do work. I write down here. Energy, it is the ability, or you can say the capacity of an object to do work. So whenever you are asked to define what energy is, you just put this statement out. Ability or the capacity of an object to do work, or you can replace the object to a system. Ability or capacity of a system to do work. Okay, so it is the tendency of you carrying out work. Okay, so energy, okay, we don't have to talk about the types of energy lah. You know that already. We have kinetic energy. Okay, we have kinetic. Learn this in your form, lower form. Kinetic energy is simply energy due to the motion, where anything that is moving possesses kinetic energy. And then we have chemical energy, CE. Chemical energy is like energy stored in the molecules, energy stored in food substances. Okay, so when you consume these foods, all these food substances break down in your body, and then it releases the energy, and this energy is being absorbed by your body cell. Okay, next we have sound energy due to the vibration of anything, guitar strings, vibrations. Okay, so you have sound energy. We have also nuclear energy, nuclear power plant. Okay, so they use the radioactive material to generate heat energy. Okay, and what else? We have potential energy. So potential energy, you have two types. First is the gravitational potential energy. I write down GPE. And of course, we also have this elastic potential energy. Okay, elastic. Difference, potential energy, gravitational potential energy. Actually, we have one more. We have also electric potential energy. Okay, but these are just two main one. Now, gravitational potential energy 是什么来的? Is the energy that due to sorry, let me rephrase. Is an energy due to an object being lifted above the ground. Okay, any object that is above the ground possess potential energy. And elastic potential energy is energy due to compression and extension, just like a spring. Okay, if you compress a spring, what do you feel? Just imagine if you press a spring. Okay, I don't know if you have ever pressed the car absorber. You know the car, we have inside the car, right? You have this very thick string, right? Very 很厚的这个 spring, okay, and very huge. It's very, very hard. It's impossible for a human to press it. Okay, this car absorber. So I imagine you try to press this spring between your arms. You press it. Okay, what happens is that you will feel the repulsion. You will feel the repulsive force, right? So when you press, then this spring also possesses this elastic potential energy, and it tends to push it back against you, right? It tends to push it back against you. So this is the work that I'm referring to. It tends to do work. Okay, any object that has high energy, it tends to do work. Okay, now, okay, consider an example here. Now, to understand more about this one, let's say I'm holding same. Let's take the same example, the box. Imagine I'm holding this box here. 10 meters from the ground. What happened is now I'm still holding it. Okay, so the box here, it possesses potential energy. Okay, it possesses potential energy, meaning that energy stored when being lifted. Now, what happened when I let go is that because of the potential energy stored in this box, so the moment when I let go, the box tends to do work by itself because of the stored energy. Okay, so if you think back about the definition of energy, it is the ability for an object to do work, right? So if it has high potential energy, then it has high ability to do work. So the moment when I let go of my arm, straight away it falls down because of the potential energy. So we say that work is done by the gravity on the box, right? Or you can sometimes say that work is done by the system. Okay, so if you really think about it, work done is nothing but the transfer of energy. When work is done, energy is transferred. Okay, I repeat, when work is done, energy is transferred from one form to another. So in this case, as it falls down, and the moment it reaches the bottom, all the potential energy has been converted to kinetic energy, all of it. Okay, there's no loss of energy. All of the potential energy has been converted into kinetic energy, and the amount that is converted, the amount of energy that is being converted is equals to the work done. Right down here. Okay, I want you to highlight this one. The amount of energy transferred is equals to the work done. So let's say if I want you to calculate what is the work done of this system. Okay, so the height is the height is 10 meters, and let's say the weight of the box is 50 Newton. Okay, so work done equals to, first you have to make sure is and the motion in the same direction. Yes, they are moving down. Okay, so work done equals to force of 50 N times the displacement is 10, so 500 joules. The unit for work done is joules. Okay, now notice that joules is the same unit as energy. So in this case, we say that work is done. How much work is done? 500 joules. How much energy is transferred? 500 joules. How much energy is transferred from potential to kinetic? 500 joules. It's the same. Okay, energy transfer, same as work done. Remember this one. Now, second example. Instead of dropping a box, now you lift it. Okay, actually all the examples I can use the same object, the box. Okay, 2 kg box. Imagine you lift it in 5 meters. Calculate the work done. W equals to F times distance. What is the F here? The F is the lifting force that you use to lift up the box, right? So it is equal to the weight of the box. 20. 2 kg times 10, the gravitational field strength. So it's 20 times 5 meters, right? So 100 joules. So when you lift the box from point A, let's say here is point A to point B, you have done 100 joules of work on the box. Okay, and at the same time, the box gain 100 joules of energy. Okay, box gain 100 joules of energy, and at the same time, you have done this 100 joules of energy work. Okay, so energy is transferred. In this case, is transferred from chemical to potential. If we skip the kinetic, okay, we skip the process here. When you lift it, the energy comes from where? Comes from your body, your own chemical energy. 100 joules going out of your body, and it is being transferred to the box. Now the box gains the 100 joules. So if I were to write this sentence here, we can write as the chemical energy loss will be equals to the potential energy gain. Understand this concept here. This one, you use it in every calculation. Now you don't see it. Now you don't see it. But later when you do the exercise, you will see it. Okay? Whenever there is one energy loss, the other energy gain. Okay? So chemical energy loss equals to potential energy gain. Kinetic energy loss equals to potential energy gain. So the total amount of energy will never change. It will not decrease. It will not increase. It will be the same. Okay, so this comes down to the conservation of energy, which I'm going to talk about. Okay, the conservation of energy. Now, before we go to conservation of energy, simple formula for kinetic and potential. Okay, 等一下，我这边剩下1分钟，我再 invite 你们，然后你们再进来。Okay, let me.